Have you ever really stopped to think about the invisible magic that happens the second you connect to a network? Well, today, we're going to pull back that curtain. We're going to take a look at your network's unsung heroes, the hidden infrastructure that works just like a digital post office, making sure your data gets exactly where it needs to go every single time. You know, it's one of those things we just take for granted, right? You flip open your laptop, connect to Wi-Fi, and bam, you're online. You type in a website and you're there. But how? How does your device get its own unique spot on the network, and how in the world does it know where to find anything? It's not actually magic, but honestly, it's pretty darn close. So the secret sauce here is two absolutely critical services that are the backbone of pretty much any modern network: DHCP and DNS. Think of them as the two most important workers in our digital post office. They're the ones making sure every single piece of digital mail gets delivered to the right address. All right, so first up, let's meet the address clerk. Their entire job was basically created to solve a very real, and let's be honest, a very tedious problem, which is just perfectly captured in this old IT support ticket. You can just feel the frustration in this request, can't you? I mean, just imagine having to assign a unique numerical address to every single phone, laptop, and printer by hand. It would be a total nightmare of spreadsheets and typos. This is exactly why they needed an automated solution. And that solution is DHCP. It stands for Dynamic Host Configuration Protocol, but you don't need to remember that. All you need to know is that its job is simple. It's the helpful clerk at the post office. When a new device shows up, DHCP just automatically hands it a unique street address, that's the IP address, so it can send and receive data on the network. No more manual entry. Now here's the really cool part, how it all happens. It's this super quick four-step conversation called the DORA process. First, your computer discovers the network by basically shouting, "Hey, I need an address." The DHCP server hears this and makes an offer. Then, your computer formally requests that specific address it was offered. And finally, the server acknowledges the request, making it official. DORA. It's like this polite little digital handshake that happens in milliseconds. Okay, so our device has an address. We're on the map. But addresses are just a bunch of numbers. We humans, we prefer names. And when those names don't work, well, that leads to another classic IT ticket. This is a classic identity crisis for a computer. You know the server is there because you can reach its numerical IP address. But when you try to use its friendly human name, the network has no clue what you're talking about. This is exactly where the second key worker in our post office comes into play. Meet DNS, the domain name system. Look, if DHCP is the address clerk, then DNS is the network's phone book. Its entire job is to look up the friendly names we all use, like server01 or google.com, and translate them into the numerical IP addresses that computers actually need to communicate. So, inside that phone book, you've got a few key types of entries. The most important one is the A record. Think of this as the main official listing. It links a device's name directly to its IP address. But you can also have CNAME records, which are basically just nicknames. So, for example, an alias like web can simply point to the official A record for your server. It's a really simple but powerful way to keep everything organized. So we've got our address clerk and our phone book operator. Now, let's see how they work together to officially welcome a new computer to the corporate network. This is where we make it all official. And this is the moment it all comes together. A computer gets its address from the DHCP clerk. Then it uses the DNS phone book to find the main domain server and introduce itself. It's only when both of these things work perfectly that the computer can officially join the corp.local family and be recognized by every other device on the network. Okay, but we all know that technology doesn't work perfectly all the time. So what happens when things go wrong? How do you, the user or the technician, talk directly to these invisible services to figure out what the problem is? Well, that's where your toolkit comes in. Here's the thing. These command line tools aren't just some cryptic commands for tech wizards. They're actually just direct questions. Typing ipconfig/renew is basically like walking up to the DHCP clerk and saying, "Hey, can I get a new address, please?" And NSLOOKUP is like flipping open the DNS phone book and asking, "Hey, what's the IP address for this server?" This is how you start to diagnose problems yourself. So, let's just boil this all down. What are the key takeaways? Number 1. DHCP is your automatic address clerk, and it uses that quick DORA handshake. 2. DNS is your essential network phone book. translating names to numbers. And 3, and this is the most important one, they have to work together. They're a team. If one of them fails, your digital mail just isn't going anywhere. You know, it's so easy to take this stuff for granted, but every single time you connect to a network, you're witnessing this perfectly coordinated dance between these two foundational services. They do all the heavy lifting in the background so that our complex digital lives can feel completely effortless. But here's a final thought to leave you with. This entire system we've talked about is built on trust. We trust the phone book to give us the right number. We trust the address clerk to give us a valid address. But what happens if a bad actor gets in there and that phone book starts to lie? What if it starts sending you to the wrong place on purpose? Well, that's where this simple, elegant system opens up a whole new world of cybersecurity.